Hi guys, so if you've been watching my YouTube channel over the last few months, arguably the last couple of years, but certainly over the last few months, you may well have been catching up on some of the Wargames videos that I've been making. So the whole thing started some time ago, probably about 10 years ago actually. I just wrote the login Joshua sequence on a Sinclair QL, and then it kind of evolved. I built myself, you can see over there, an IMSAI 8080 ESP, so that's an IMSAI 8080 replica, and decided that since that was the machine that was actually used in the Wargames movie as the terminal to access the WOPR and other systems from the Wargames movies, that I'd rewrite the code in Basic 80 on that machine, and that's all great, except that it's only got 64k of RAM, and even with the image that I was running, I still didn't have enough memory to actually write all of the code and still compile it. So there is an interpreted version that will happily run on the IMSAI 8080, but to overcome some of the limitations that I was having, let's just fire that up so we can get some pretty lights whilst we're going through this. So to overcome some of the limitations that I was having, and to be able to include other features like connecting out to ARPANET, albeit simulated, connecting out to the internet, and also including things like the samples for the voice of WOPR itself, I decided to rewrite it, but in this time in C on a Linux platform. So if we just move the camera around, so initially I did most of the development on this little box here, so a Raspberry Pi 4 and a Despi case, but you know, it's Linux, it's Debian Linux, so it didn't really matter whether I did it on that or whether I did it on this box down here, which is actually a Mac Pro 5.1, but it's not running Mac OS, it's running Debian Linux, or Linux Mint to be specific. So I could, those two machines are fairly interchangeable. What I tend to do now is do most of my development on the Mac on the Mac Pro, albeit running Linux, and then once I've developed the code, I moved across to the Pi to test it, because that's obviously more accessible for anyone that wants to run the Wargames software suite now. It's multiple applications. Right, so I'm not going to bother switching over to the capture card for this. I'm just going to show you on here very quickly. So I'm using Visual Studio Code as my IDE, just to develop the code. And you can see here there's a number of different programs. Hopefully you can see there. So the first one is the IMSAI 8080. So that simulates the IMSAI 8080 running CPM 2.2, not that it makes too much difference, and gives a few basic commands. So clear screen, dialer, dir, by, and Kermit. Kermit's used to access the school computer, and the dialer is effectively a war dialer, and it's used to find other systems. So all of this will get demoed in a bit, but I'm just kind of talking through the approach. So effectively what that does is launch other applications. So Kermit is just embedded within this code, albeit simulated. Dialer is actually a separate program. So if we look here, here's the dialer. This is a bit more complicated in terms of the way it works. And this is reading in a systems list text file, data file, which has got details of all the systems that you can scan for, and as it finds them, it'll then write it out to systemsfound.txt, another data file, so that the next time you go in, you can view the list, and anything that you've already found you don't have to search for again. That's basically the way it works. So I'm not going to go through every single line of code, But if you can see here, we're also using some external system commands to use the aplay command, which is a standard binary within Linux, so that we can output the samples that we want to use from the movie to the sound card. That's basically the way it works. The dialer then will connect to a number of different systems depending on what's in the systems list text file or systems list data file. Some of them are predetermined, and they include WOPR, as you might expect. WOPR in turn will allow connection out to other systems, also to Pan Am and to the bank, but also to ARPANET, and in fact anything else that we include in the systems list file. So I'm going to show you the systems list file real quick, just to give you an idea. So here you go. If we look at systems list.txt, okay, now this is, I appreciate, going to be a little difficult to see. Let's zoom that in just a little bit. Okay, but effectively it's just using a flat file. Each of the fields is stored on a separate line in this data file. So here, if we look at the first one on the list, so the number, the phone number is, phone number for the modem line in this case, is broken down into the prefix and the actual number itself, and the area code, in this case 311, is currently fixed. So we're not actually doing any processing on the area code, but we are doing processing when we scan for the prefix and the number. And then the name of the system, in this case, here you go, this one's called ARPANET, and then the file that it's going to execute is telehack.sh, so that's just a script. And similarly with internet, you got the prefix, the number, the name of the system, and what it's going to do. So in this case, it's going to run internet.sh. And there's, I think I currently set the limit of the number of systems to 100, but there's no particular reason why that needs to be restricted. That could be as many as you want. And that's it. That's basically systems list. So there are a whole load of other data files for different purposes, but I'm not going to go into details of every single one. We'll be here forever. Okay, and WOPR is probably what most people would be interested in. So this is going to effectively go through the sequence of the movie. Not quite, because obviously we can't magically be at NORAD, so we're having to simulate and kind of manipulate the sequence of the movie slightly so that we can get it to fit. But in essence, it's about as close as it can be. Let me zoom that back out. Okay, so that's the source code, and in terms of the number of lines of code, the WOPR code itself, and this is all written in C, so currently we're at 2,455 lines of code for WOPR. The tic-tac-toe game, which does actually simulate crashing the system to take down the missile systems by monitoring the CPU utilization and putting a load on it by increasing the speed that it plays the tic-tac-toe game in 0 players. And it's using character maps to generate the noughts and crosses on the grid. So that is currently 546 lines of code. IMSAI 8080, that's pretty simple program, so 139 lines of code for that. The school computer is currently 419 lines of code. Pan Am, which does actually include a fully functional database, is 348 lines of code. The bank that's probably the simplest program. It doesn't really do very much. That's 80 lines of code. Dialer, which does actually do quite a lot, because it has to go through and scan all the numbers within the range you specify, play relevant samples, blah blah blah, lots of stuff there. 579 lines of code. And the original, I haven't even typed that up, but it's a fair few lines of code. The original basic program from the written in Basic 80 on the IMSAI 8080, it was 822 lines of code. So it's grown considerably since that point. So let's have a look. If we connect to, right, so I've already got the Raspberry Pi, as you can see, just down here. So I've already got that up and running. I've not actually got it connected to a monitor, so I can't show you effectively it's running headless, but I've got some scripts running on it, so it'll automatically start up all of the Wargames services. So all of the different computer systems from the Wargames movie are effectively running as individual servers or individual TCP listeners, but also so is the IMSAI 8080 service. So I can connect to that and then from there connect out to all the other systems, or I can connect to them independently. I'm not going to go into too much detail on that. Let's just show you this. So we've got the IMSAI 8080 up and running. If I use the IMSAI 8080 ESP terminal, that should hopefully connect directly to the IMSAI 8080. And just to prove there's no smoke and mirrors going on here, if we look at the shortcut there, okay, so that is running, just zoom that in a little bit. So that's running a script called IMSAI 8080 term. If we have a look at that script, okay, what that's doing is running cool retro term, which is how we get the effects to make it look like an old CRT. -E tells it that we're going to run another application with it, and we're running Kermit in this case, and effectively we're connecting to TTY USB 0 at a baud rate of 115/200. And we're using VT100 terminal emulation. So effectively what that's going to do, the IMSAI 8080, if I just zoom back out, so the IMSAI 8080 has got an RS-232 connection down to the Mac Pro 5.1. So we're using this as our terminal into the IMSAI 8080. Then the IMSAI 8080 is connecting to the Raspberry Pi via Wi-Fi. So that's how it's connecting to the services on the Raspberry Pi. So in this case, just to reiterate the point, the Mac 5.1 is nothing more than a terminal in this instance. The fact that I happen to use it as a dev box as well is kind of academic. So that's a local connection, local serial connection. Okay. So what we're going to do here is we're going to run Kermit on the IMSAI 8080. We're going to set the port, in this case, to UC1. Now obviously if you're running a different CPM machine, then your port assignment is likely to be different, but the principle will be the same. So I'll square this up a little bit. Okay, that's probably as good as it gets. So if we connect to that and then issue an ATD, in this case I can just connect to the host name, which on my LAN will be Desk Pi, and we'll connect to the IMSAI 8080 program. We could skip that and go straight to the WOPR, but we'll go through the whole thing quickly. So there we go. And if I just switch the sound card over so that the Raspberry Pi is outputting its audio to the monitor, then you should be able to hear the sound effects. Let's just turn that up a little bit. Okay. So what we're in now is the simulated IMSAI 8080 being hosted on the Raspberry Pi, but it effectively looks and feels, hopefully, almost exactly the same. So if we then run Kermit on here, now I've set it up, I've programmed it so it will automatically set the port for you, so you don't have to know what to do there, and then all you have to do is type connect, although if you were to press type question mark, it would tell you that that's your option, and then it'll automatically dial the system, in this case the school's computer. Okay, so there's some basic password checking here and masking of passwords and things like that, which actually technically doesn't happen in the film or the movie. It doesn't mask it. When he types in pencil as the password, you do see it in clear, but hey, I thought we'd improve on that slightly. So I'm not going to go through all of this. There's already a couple of records, or a few records in there for David Lightman and Jennifer Mack, so we can search on those. And we've got the option to edit or delete records, and it's actually maintaining all of these in a fully functional database. So we can change any of those, or we can add additional records, or we can create additional records for new people. We can do whatever we want. But again, we won't go through all of that. It's on the software's all up on GitHub, so you can try it for yourself. Okay, so we can come out of there. And then this time we'll run dialer. Let's just move that down a bit so it's easier to read. Okay, so we can look at view. Now these are all the systems that we've already found, but we could scan for more, and if you'd added some more into the systems list, they probably weren't a good choice, but we'll do it anyway. And you can change the prefixes as you go, and it'll use whatever you type in. But obviously you need to have some entries in the systems list that correspond, otherwise it's not going to find nothing. And you can hear there it's got some samples, and it's playing these randomly but with a few conditions.
If you are obsessive compulsive, press 1 repeatedly. If you are codependent, ask someone to press 2 for you. If you have multiple personalities, press 3, 4, 5, and 6. If you are paranoid, we know what you are and what you want. Stay on the line and we'll trace your call.
Okay, so the range that I gave it was never going to find anything, but the samples that we're using, they can be changed. They are actually hard coded, but you could change them quite easily by just going through the dialer code and substituting them. If you wanted to have more random samples, it's a really easy change. So this time let's give it a range where it is actually going to find something. So if we go from 1082 rather to 108. What? Let's try that again. Scan 1082 1084. The VT100 escape codes don't quite work the way they should when you're using Cool Retro Term, unfortunately. So if I make a mistake, I can't backspace on it, so that'll be why. If you just use the built-in terminal emulator on Linux, that doesn't happen, it's fine. Okay, so again, we'll just go with the standard prefixes for now. Typical. Invalid prefixes. Well, that's good. At least the validation's working. Okay. So when it finds a hit against the systems list.txt file, it'll invert the characters like that. Now it doesn't do that in the film, but it's just easier to see what it's doing, I think, so that's why it's done that way. Okay, so there we go. And eventually you build up an entire list. I mean, you could leave it running from 1 through to 9999. It would probably take you a couple of days, but it would get there eventually. So I've included some extra systems here. I'll just zoom that in a bit more. So we've got ARPANET. Obviously ARPANET doesn't exist anymore, but ARPANET in this case is simulated using telehack.com, which is a great site, if you want to call it that, to play around with systems the way they used to be back in, well, probably the early 70s on the ARPANET precursor to the internet. So we're not going to do too much with it except just prove we can connect to it. So it'll use DTMF tones and a 1200 baud modem sample to simulate connecting to the system. The modem, so the DTMF tones are actually all the same at the moment. It's not using a DTMF dialer. It is something that I might look to include at some point, but at the moment it's not. So I'm not going to go through the whole of Telehack. You'll need to play with this yourself, but we'll just run a few basic commands. Now I'm not logged on at the moment, so there's only so much you can do with it, but you can see it kind of looks like old school internet connectivity. You've got a few basic commands there that we're using, netstat, ping, things like that. Okay, and then once you're finished with it, you can quit out of there, and that should disconnect and take you back to the list. Internet, this is going to use FrogFind, or it's going to use a Lynx browser, so a text-based web browser with FrogFind to basically allow a text-based experience of browsing the internet, but with all the stuff that you can't do anything with. So images, JavaScript, Flash if there is any left out there, all that kind of stuff. It'll filter out and just present everything as text. Okay, there we go. So we can search for whatever we want, IMSAI 8080, click on Ribbit, and up it comes with some hits, and then we can cursor down to whatever we want to look at, and it'll present the articles and we can read through those. Once we're finished, we can just quit out of there. That'll disconnect us and take us back to the list. So we've got Bank, which is Union Marine Bank in this instance from the film. Now, of course, just to reiterate the point, all the sound, so all the samples, noise, and whatever else, all the dialer noises, they're all coming from the Raspberry Pi that we just looked at. Unfortunately, there's no way I can easily get them to come out of the actual IMSAI 8080. That would be nice, but I'm afraid not. So the IMSAI 8080 in this case is just acting as a terminal. Okay, so the bank is pretty much the simplest program we've got. So it doesn't matter what username and password you put in at the moment, it'll mask out the password, but it won't actually connect you to anything. So you can put in whatever you like. There's no more code there. Obviously that could be developed further in time. So F will take you to Pan Am. Okay, so you've got the option here to create a passenger reservation by pressing 2. I've already done that, so we'll go for option 3, and we can look at reservations for Lightman, for example, and you can see there he's already got a reservation. Flight schedules is something that I plan to include, but I just haven't had the chance to do that yet, so we'll come out of that one. You can see there we've got some dummy systems as well, so we can fill those in with other entries to connect to other systems or do whatever we want, but there's nothing on them at the moment. If we select option I for the WOPR, obviously in the movie you wouldn't know this was the WOPR until you'd actually connected to it, but you know, you can leave the entry blank. You can amend the systems list .txt file to say whatever you want. So, okay, so we get to the logon prompt, and as in the movie, we've got the option to ask for help. Obviously, there's no help available. Or help logon, again, no help available. Help games. Okay. We can see that gives us the output that we'd expect based on the film, and list games as well will also work at this point. Okay, and the backdoor account Joshua will get us in, and you can see we've got the random characters as per the film. Okay, so here you can have your rudimentary chat with Joshua or WOPR, but there's some other things that you can do. So if we just type help, it'll give us a few tips here. So help, well, we just proved that works. List, date, time, DEFCON, author, users, ARPANET, internet, and exit. Now some of those are probably self-explanatory. List can be expanded. At the moment, list space games, obviously we know what that does. Date, time, DEFCON shows us the current DEFCON status, and this will change as you're playing the game as well. Author, well, that'll be me obviously. Users, so if we list users, I've already created a couple. At the moment, access level 1 is a standard user, access level 2 is a sysadmin. May well change that. One of the suggestions that we had was to have 5 levels of access. That's an easy change, but I haven't done it yet. Go back to, oops, select option. That's right, sorry, taking this out. Okay, ARPANET, that's going to do the same as it would do on the dialer, as will internet, except that it won't dial first because WOPR's already connected to those systems. So they work, and exit will take us out. We're not going to do that though. What we're going to do, there's one undocumented feature, by the way. CLS will clear the screen. So if we carry on with the chat with WOPR, we can type hello. How are you feeling?
Excellent. 15 for our time. Can you explain the removal of your user account on June 23rd, 1973?
Okay, you can pretty much type whatever you want as long as you hit the keywords. So the first keyword for how are you feeling today was fine. The next keyword, when I can type, people will make mistakes, should have been people, but I can't backspace at the moment. But it's got mistakes in there, that's the keyword.
Yes, they do. Shall we play a game?
Again, at this point, he'd say something along the lines of, yeah, love to, let's play global thermonuclear war. But actually, all you've got to do is hit the keyword of nuclear.
Wouldn't you prefer a good game of chess?
And again, you can type in whatever you want as long as you hit the keyword, which in this case is later.
Fine. Which side do you want?
Okay, you can actually pick either side, but obviously in the film he plays as option 2 for the Soviet Union. And depending on which side you select will determine which side the missiles get launched from. That's basically all there is to it.
List primary targets.
So for primary targets, they can be whatever you want. It doesn't do any kind of validation on them. All it does is restrict them to a maximum of 4. If you don't type in 4, that's fine. When you hit return again, if you've only typed in 3, it'll take 3. Now, one suggestion was that we gave the option to maybe go back and edit them. I think that's a good idea in case you type them in incorrectly, but really, it's not going to make any difference to the gameplay, but it's on the list of things to do. Oops. Excuse the typo. And again, I'm trying to work around my camera tripod here, so that's a bit awkward. And obviously we can't use the backspace. So ignore the typos, but you'll get the idea, all right? So we typed in 4 and it automatically goes, well, you've had your 4, that's it, we'll carry on. Okay, now at the moment you've only got one option here to launch. The options that I'm going to include at some point are edit, to go and edit the primary targets in case you typed them in incorrectly for whatever reason, or exit, so if you decide you don't actually want to play the game anymore, you can just exit and it'll drop you back to the menu and you can carry on talking to WOPR. So those couple of options. If you can think of anything else you think would be worth including, by all means let me know, but that's the plan at the moment. So we'll click L for launch. Okay, so we get to the point where we've launched the missiles, and in the movie, this is pretty much where his David Lightman's parents call up to him and say, "We're barbecuing tonight. Do you want to invite your little friend?" Blah blah blah. And at that point, he disconnects, or he goes down to clean up the bins and disconnects, whatever. Obviously, it's a little difficult to write that in without having a whole load of text to explain what's going on, which in the basic version of the program I have included, but I haven't on this because I wanted it to kind of flow a bit more. So at this point, you've got the option to press enter key to continue, and then it'll effectively disconnect. Now, the logic behind this is that when NORAD discover that there's an open line in Sunnyvale, California, in this instance, they disconnect the session. They terminate the number so that he can't call in. But it doesn't matter because, of course, in the film, WOPR or Joshua calls him back. So we'll see how that plays out in this case.
We're sorry. You have reached a number that has been disconnected or is no longer in service.
Okay, so there you go, disconnected, and then Here you go, WOPR's calling him back.
Greetings, Professor Bolton.
Okay, so when we get to this point, this is where it kind of helps to have some knowledge of the film. But I'm pretty much guessing that if you're watching this video, you're a Wargames Anorak. Maybe. Okay, so you've got the option here to say incorrect identification. I'm not Falcon, blah blah blah. I mistyped it again. Excuse
Sorry
me.
to hear that, Professor. Yesterday's aim was interrupted, although primary goal has not yet been achieved. Solution is near.
Okay, so the keyword on that one was incorrect. So as long as you've got that in there, you can type whatever you want. And then at this point, David Lightman says, what is the primary goal? But if you've got the keyword as what,
You should know,
then it's
Professor.
fine, it'll work.
You programmed me.
And then again, he asks, what is the primary goal? Again, the keyword is what. The program's been written in such a way that it's just going to keep a track on the number of times you ask it, so it knows how to respond to you.
To win the game.
Okay, to win the game, useful, right? And then he asks, are you still playing the game? Now, actually, he asks this. All of this sequence is when he's at NORAD, but clearly we've modified the script slightly, so he's doing all of this from home. It's the closest we could make it.
Of course. I should reach DEFCON 1 and launch my missiles in 28 hours. Would you like to see some projected kill ratios?
Doesn't really matter whether you want to see them. He's going to show you anyway. Okay, and then at this point he says, he asks, is this a game or is it real? But real is the keyword, so that's the only one you need.
What's the difference? You are a hard man to reach. Could not find you in Seattle, and no terminal is in operation at your classified address.
Okay, at which point he asks what classified address, and as long as you've got the keyword address in there, it'll work.
DOD pension files indicate current mailing at Dr. Robert Hume, a.k.a. Stephen W. Vulcan, 5 Tall Cedar Road, Goose Island, Oregon.
Okay, all useful information, but it's not like we're actually going to go there and visit him in person. In the basic version of this program, it does talk you through that and simulates that occurring. But I mean, feel free to play with the basic version as well. Now, actually, the counter isn't quite the same as it is in the film, but he does say 28 hours, so I figured we'd go for 28 hours. Now, this is now simulating us being in the war room, so hence Terminal Echo War Room, which is my workaround to how we're not actually able to be there in person. And we're riding out the inbound attack, but we're seeing no impact, which is what we'd expect, obviously, because it's just a simulation at this point. Okay, and then we proceed into WOPR trying to guess the launch codes. Now, actually, this will never play out quite the same way twice. It'll always eventually get the launch code, but it's essentially generating random characters, and if it gets a match, then it'll clock off that position on the launch code until it gets all 10. Now, it would have been a bit difficult to run it the same way as in the film, where all 10 characters are rolling over at the same time, because we're doing this with characters in a VT100 terminal emulation. So the closest we could get without killing the connection off. Bear in mind that even though we're connecting this over the network, so that's as fast as the network is here, but you know, let's call it 50 megabits or 100 megabits, it doesn't really matter. The limiting factor is the speed at which we're connecting our serial connection into the IMSAI 8080, which in this case is 115.200. So there's that to bear in mind, and that is even more of a limitation when we come onto the tic-tac-toe game, as you'll see, and I'll explain it when we get there. Okay, so it's got the code. Obviously in the film he starts playing tic-tac-toe before it completes getting the code, but that would have been a bit difficult to show. So it's got the code, but it hasn't yet launched. We now have to defeat WOPR so we can get it to stand down the missiles. Now we can play one player, but that's a fruitless exercise unless you happen to want to play tic-tac-toe or noughts and crosses. So the noughts and crosses game is using noughts and crosses, tic-tac-toe, depending on which side of the pond you're at. It's using AI logic to play the moves, and if you can beat it, I'm impressed. You shouldn't be able to beat it. The computer will always, at worst case scenario, draw with you. But we'll go, here you go, B2, X in the center square, right? A2, C1, B1, C3, and you can play it as many times as you like. It's always going to be a draw, but this isn't what we need to do. What we need to do is beat the computer. So we're going to say play again, yes. Number of players 0 as per the film, and how many games are we going to run. Now we could just let it run, but there's a reason for specifying the number of games. Depending on the processing capability of the system that you're running on, there are various parameters that you set within the code to compensate for the fact that you might be running on a really fast machine. Now in this case we're running on a Raspberry Pi, and it's not too difficult to max out the performance on a Raspberry Pi. So I think in this case I've set the CPU threshold to 60%, and I've set the number of times that it has to hit that threshold to 2, and that seems to be about right. So we should be able to play 10 games, and that should be enough to trigger the CPU overload. If I were playing on a faster machine, I might have to play considerably more games and reduce the threshold at which it would hit the CPU overload. That's a lot of waffle, but if you look at the source code for the tic-tac-toe game, there are some notes in there, so hopefully that'll become a bit clearer. But also, given that we've got a limitation of 115, 200 baud, we can't actually play this game too fast. So playing it on a Raspberry Pi and having it hit that threshold quite soon is not such a bad thing. And you can see it can't actually keep up with drawing the characters.
Must be caught in the loop, storing more and more power from the rest of the system.
And you can see that it's still drawing the characters, even though it's already triggered it. But it's there or thereabouts. Okay, and there's a bit of a delay just to make sure it finishes the game. Okay, greetings Professor Falcon, which is what happens in the movie. At this point we can actually type in anything we want. There's no validation on this input at all.
Strange game. The only winning move is not to fail.
Now you might be tempted,
How
rather.
about a nice game of chess?
Yeah, I was going to say you might be tempted to type something between the delays there, but just wait for it, it'll get there. So if we type DEFCON, it's back to 5. Had we looked at it earlier, it would have been down to 3. And if we'd failed to defeat WOPR, we would have got a different message. And then DEFCON would have been at 1, and effectively World War 3 would have commenced. Simulated only, fortunately. So that's where we're at. And really, that's kind of the end of the game. But obviously, you can carry on playing around with it as much as you want at that point. So we can go look at the list of users. We can create new users there, delete users, do whatever we want. We could go and surf the internet using our, oops, try that again. We could have surfed the internet using our links browser or done whatever. Now, let's just look at that list of users again. So you can see here, I've got 2 users there. One of them, so mine, Andy, is an access level 2. So if we come out of here, let's exit. Well, that'll effectively take us back to the dialer. If we go back into WOPR, okay, but this time we'll log in using my account instead of the backdoor account. Oh, I've got that, mistyped that. Let me try that again, sorry. This is the problem with using a cool retro term. It looks very, very slick, but yeah, unfortunately the escape codes aren't working the way they should, but never mind. Okay, let me try that again. Okay, and now we've got the little intro log on screen there. Welcome to NORAD, etc., etc. Okay, and a hint there as well. Type help for a list of commands. So we can do that. Type help. Okay, and you can see there help list, date, time, DEFCON, author. We've already looked at all those. Users, we've looked at that. Mail. Who am I? ARPANET internet we've already looked at. Tic-tac-toe, well, we know what that is, but we can launch it manually if we want, if we particularly want to sit there and play noughts and crosses. Backdoor and exit. So let me show you some of these, all right? So if I go into mail, and I can go into create. If I try and send to a recipient called Fred, who I know doesn't exist currently, it'll tell me user does not exist and take me back. If I try and send to a user called Emma, who I know does exist, and just put the subject in a test, messaging as test 1, 2, 3, 4, 5. Okay, as soon as you hit return, it'll send it. You can keep on typing with punctuation, whatever you want, but as soon as you hit return, it will send it. See, email sent. If we then look in sent items, we can see there, I obviously sent one earlier, which I haven't deleted. So there's a couple of sent items. I can view those. So if I select option 2, there you go, it'll show me the message that corresponds to email number 2. And then I can do 1 to return to the list, 1 to go 0 again, go back to the menu. If I just, I'll tell you what we'll do is we'll come out of here. If I exit, this time I'll go in using Emma's account. Okay. Now we'll log in using Emma's account. Again, look and feel exactly the same. Okay, and if we go into mail and look in inbox, there you go. Take option 2, that's the message we just sent. And I've got the option there to reply to email, so if I do that, and we'll just say message, got it, thanks, or whatever. Email sent. Back to the menu, we look in sent items, you can see there's a couple of messages. Alright, so if we exit from there, let me show you something else whilst we're here. So we'll just go back to our list of commands, go into users. Now Emma's got a level 1 account which doesn't have permissions to go into administer the users. So that's the reason for having different users access levels. Alright, so if we come out of there, this time we'll go back in using my account. Okay. All right, and we'll go back in to mail. If we look in inbox, there you go, we got the reply, number 2. Got it, thanks. Okay, now I'll show you this as well. So if we just come back to the menu, go into housekeeping, we can delete all inbox messages and all sent items. And then if we look in our inbox, there you have no mail. Look at our sent items, you have no mail. Now the way this works, it's a flat file database effectively. It works much the same way as say something like MS Mail would have done back in the day, or CC Mail, but it doesn't offload to a local inbox or a local mailbox. It's just storing it all in the data file. So effectively, when I delete my sent items or I delete my inbox, then it doesn't matter that they were sent to someone else or from someone else. It'll delete all instances, which is great. I wish all email worked that way, but it doesn't. So that's it. It's a real simple system, but that's basically how it works. Obviously, it could be enhanced, but it's only a simulation, so I didn't see the point. Okay, so we're already out of there. Let me show you something else. So in the movie, it talks about, oh, we've taken out the password for the Backdoor account, or the Joshua account, and this was a suggestion, and I thought it was a really good suggestion, so I've included it. So if we go into Backdoor, so this is the Joshua account that it's talking about. If we say disabled, what that's basically doing is updating a text file called joshua.txt, and it's literally just setting it to enabled or disabled. It's enabled by default. If we then come out of here, so I log off, and this time we'll try and go back in using the Joshua account, so the Backdoor account. Okay, there we go, Joshua. Okay, there you go, taking out my password, can't get in. So that's how you disable the Backdoor account. So you probably want to re-enable it. So we'll go back in and just re-enable that. Okay. Oh, messed it up. Sorry. Let's try that again, shall we? Okay, I'll just pull up the menu again with a list of commands. I'll just show you this. We can also type "who am I," which is more useful if you've already cleared the screen or scrolled off the bottom of the screen, and in the unlikely event you forget which user account you logged on with. So again, into backdoor, and we can set it to enabled. And if we come out of there and then go back in,
Greetings, Professor Bolton.
okay, so we can see that that's working again now. So we'll exit out of there and back out of the dialer. That's effectively taken us back to the simulated IMSAI 8080, and when we're done with that rather, we can type buy, and then you can see it's come up, no carrier hang up. So that's effectively disconnected, and if we do a Control/C, now that's actually taken us out to the local copy of Kermit on the terminal machine, which in this case is the Mac Pro 5.1. And the reason for that is it gets a bit confused as to which machine is supposed to trap those escape codes. Had we used a different terminal emulator, that wouldn't have happened. So just for the purposes of, I'm going to come out of here and I'm going to go back in using a different connection. So if we run screen/dev/tty USB 0115200, okay, just make that window a bit bigger. Okay, so we won't have the same problem now with the escape codes or the VT100 emulation. Backspace will work. So if we do Control/C, quit out of Kermit, this is actually type quit out of Kermit. That is actually on the IMSAI 8080 now. Okay, and that, I probably missed a few features, but that's pretty much it. And what's that, about an hour's worth of video? That's almost as quickly as I could have done it. Still more to come. There's still quite a long list of feature requests and other stuff that I intended to include, so I'll carry on working on that. But hopefully, if you're playing around with the software and you weren't sure how things should work, maybe this will help you out a little bit, and maybe it'll show you a few features that you didn't know existed. Anyway, that's it for now, guys. Take it easy, and I'll catch you on the next one. Cheers.